and welcome to Unapologetically Technical. My name is Jesse Anderson, and we're going to be going deep today because this is the show that goes deep. In fact, we'll probably be going deeper than normal because we'll be talking about some pretty difficult distributed system things that you may have hit, you may have wondered about, and we're going to go deep on that. And to do that, I have Abhishek Chauhan with me. He is the CTO and co-founder of Grainite. Abhishek, would you mind introducing yourself a little bit more, please?
Yeah, sure. Thanks, Jesse. So like Jesse said, I am the CTO and co-founder at Grainite. We've been around for about 4 years. Uh, Before this, I was at Citrix. I was a technology fellow in charge of all of their products, but I specialized in networking. I grew up on the networking side of Citrix as well. I was the CTO for NetScaler. Before that, I was the chief architect for it. And before that, the chief security architect for NetScaler. So I do have some of the paranoid blood running through me as well. Before Citrix, I was at a startup that I had created that was an application firewall that Citrix had acquired. And before that, I was at Sun Microsystems. That part is very interesting to me. At Sun Microsystems, I was the blueprints architect for J2EE, and we are now talking about 25 years ago. And those were the days when the dot-com boom was in full swing. Everybody wanted to build web applications and get online. And it was the wild, wild west out there. And when we created J2EE, it really simplified and programmatized the way you build web applications with Java. So I was part of that. Before that, one more startup that was acquired by Microsoft, and Microsoft for a little bit before then.
Well, that's quite a pedigree I'm really interested in hearing about some of those stories. And spoiler alert, we're going to get into some of those stories too, because as much as we talk about things 20, 25 years ago, there's a cycle in technology and things are going to come around. And we'll talk about that with Java. So you talked about a little bit about some of that background. What makes you so interested in data and pipelines?
Yeah, so it's interesting. I started out in applications. If you think of J2E as kind of the peak of that, I moved into networking, and networking, if you have heard the famous quote from Linus, it's like, the database guys don't have any taste, and and the networking guys are supposed to be the elegant ones. So I was the elegant one for a while, but over time, what I realized, and especially when I tried firsthand to build an application that's event driven and data intensive, what I realized is that there is just a huge amount of demand and a huge amount of need that the database and the data analysis and the data processing world has. And unlike some of the other fields like networking, this huge demand isn't all that well met today. There are sure a lot of different technologies on the data side, but most of these technologies are still fairly nascent. And I know this might sound like blasphemy to many people who have practiced databases a lot longer than I have, but I did train in the world of databases when I did my master's back at Wisconsin, which in those days was called the Institute of Databases and Other Computer Sciences, because it was just so well focused on databases. But yeah, so most recently, I tried my hand at databases or at data intensive applications. And to tell you a little more about that, I was at Citrix, and you know the I was a CTO and technical fellow, so I was on stage at a keynote. 5,000 of our best customers were in the audience, and I went up and announced a new product, a new behavioral analytics security product that Citrix was going to build. And the idea was that, when you announce these products, you expect to be able to build them in the same year that you announce them. And we announced it in May. The expectation was you'd get something out and in the hands of customers by December. Turns out that by December, we weren't even able to get the set of people who could build the concept or the vision that we had around this product. Because what we wanted was to collect a bunch of telemetry that the Citrix customers could produce, bring it all in one place, analyze it in real time, and every time a system call is made, to be able to say whether to let that system call through or to not let it through. And these were the days when some very sensitive information had leaked on the internet. Snowden and so forth was in the news, and we felt like we had the technical wherewithal to be able to do that. And Citrix is one of the top 10, or used to be one of the top 10 software companies. So we weren't completely clueless about the world of data and data intensive applications. But it was a long, long journey. It took us maybe 3.5 years before we finally got a product that we could be proud of in that space. And I'll tell you more as we go through the talk. But it was anything but easy, and it was anything but predictable, and it was anything but stable or robust, even when we were all said and done.
Yes, no surprise there that there's that narrator voice that when you said, and we were up on stage announcing this narrator voice, and it didn't happen. And it took far longer than they thought.
Yes.
Yeah, you're definitely not the only one on that. And that's part of what I try to do with the show is say, hey, just because somebody says it's easy or thinks it's easy, no, you get down into it, you hear from people like yourself who've done it. It's not easy. It's really difficult. Yeah, even for what, as you mentioned, a pretty top 10 company. So it's tough. And then speaking of being at the top, I just read that you graduated from IIT, which is the Indian Institute of Technology, and I read about what it means to get in. And it seems like it's based on just the Indian population, that there's a lot of people trying to get in. Could you explain more to people about what IIT is and what that means?
Yeah. So IIT is a preeminent technology institution, university, or a collection of universities in India. And I'll tell you, it is, if you remember the Men in Black movie where Will Smith says, these are the best of the best of the best. It's kind of like that. And I say this half jokingly. Uh, but really, in those days, there were about 2,000 people who were selected by these 5 IITs. And there were, God knows how many, maybe 300,000, maybe more people who applied for this. The university education was almost entirely free, and so it was something that equalized or leveled the playing field across the different demographics within all of India. But at the same time, you get like a 9-digit roll number when you take that exam. There's an entrance exam, lasts about half a day sometimes. So there are 3 subjects they teach or they test on. But at the end of it, couple of months later, the results are published, and in those days there was no internet. So a list of 2,000 roll numbers, which were these 9-digit numbers, was printed on a piece of paper and stuck on a wall. And you were supposed to see if your number was in that list. And this list was sorted by rank. So like the person who scored the highest would be at the top. And nobody in their right mind scans the list from the top down. So you always start at the bottom and you start matching each of those 9-digit numbers to yours and imagine there are like thousands and thousands of people, children kind of teeming around that wall trying to look for these numbers. And as you climb towards the top, your hope keep on declining because you're like, I didn't rank 2000, I didn't rank 1900s, I probably won't rank 100. And so eventually, if you do find your number, it is that much of a delight. So it's an excellent institution. It is life changing once you get in the sense that the people you are surrounded by are outstanding. They are, almost every one of them is better than you in at least one or more areas. The teachers and professors are outstanding as well. A lot of them are there out of passion for teaching and spreading the knowledge, as opposed to out of just being kind of doing a job. But having said all that, and glorified and created a folklore around IIT, I'll say this: it we selected 2,000 people. Of the top 10,000 people that applied, I would say on any given day, any of those could have made it to those 2,000 people. And what I mean by that is that the competition is so intense that if you look at the person who ranked 2,000 and the person who ranked 10,000, there wouldn't be all that much of a difference in their performance. And if you imagine that maybe 2 or 3 or 5% of your performance on any given day is just the day, just the way you woke up that day, then that tells you that, even though it's selective and it's unfortunate that there are only a small number of seats, but there are a lot of excellent people, even the ones who didn't necessarily go into IIT or didn't go into IIT that year. There and this is borne out throughout my career. I have interacted over these years with so many people, both from IITs and not from IITs, that were all smarter than me.
I think you make a really good point, and it's a point that I would tell everybody. Surround yourself with people smarter than you, not you be smarter than them. And this is, as you see with Abhishek's life, this is one of the secrets. You start to become smarter, not rather than you trying to lead the room and be the smartest. This is a key life lesson, I think, and good that you've been doing that all along. So you mentioned before about some acquisitions. So you started some companies and those were acquired. Those two companies were called VExtreme and Teros. What advice would you give to startups in today's climate where they may be either looking to be acquired because of a cash flow problem, what have you, or maybe because they've become very successful? What advice would you give them?
Uh, I think it's a fairly broad question. I have had a lot of experience from both sides of the table when it comes to acquisitions. Like Jesse mentioned, I have been part of two companies that were acquired, but one of my roles at Citrix for a long time was also to look for companies that we could acquire. So I have acquired a few. I have looked at what works and what doesn't work. From a startup's perspective, I think the most important thing to remember is that getting acquired cannot be plan A. You have a vision, you are passionate about that vision, you are trying to take it somewhere. And an acquisition, if it happens, is because it makes a lot of sense for both the acquirer and the acquiree, but it is not something that you typically want to will to happen. There's an old adage in the world of raising money, is that if you ask for money, you will get advice. But if you ask for advice, you will get money. And so the same kind of thing plays in the world of acquisitions. You don't strategize or plan for an acquisition. What you plan for is to work with different companies, to partner with them, to show them how you have mutual customers that could benefit if you guys joined hands together. And typically you join hands together by meeting in the field, as in I have a common customer, meeting on technology, that is I have got complementary technology. And then finally you look at meeting of the teams. Right. Also, as a startup, remember that many times we look at a big company and say, I don't want to talk to them because they will replicate what I'm doing. Or I don't want to talk to them because this is already in their roadmap or something like that. We should, again, having worked at a big company for a while as well, know that the soft underbelly of a large company is its lack of agility. Even if you went on a whiteboard and spelled out exactly what you do and how you do it, it will take that big company probably 3 years before they could pull it off, if they wanted to do it themselves. And no big company really wants to build technology from scratch. They would much rather build something in partnership with you that they can bring to their customers quicker rather than having the customers wait 3 more years. So I'll
Yeah.
stop there and yeah.
No, you make a very good point about opportunity cost. That's kind of what you're referring to. If you take 3 years to build whatever or to rip off, so you take that 3 years, 3 years of opportunity cost, and the company that you're ripping off has had 3 years of time to improve their product, you're now 3 years behind, or 3 years plus in some cases. So yeah, there's a lack of agility. Generally, companies would rather, and good management realizes this. So that you make a very good point there. And it's interesting that you were on both sides of that. I think it's quite rare to talk to somebody who both advised and sold, and so you're able to peer in a different way. As you bought those companies that for it sounds like at Citrix, what do you think made those company acquisitions successful?
Yeah, I think we had our fair share of acquisitions that didn't work, and some that did work, and some worked spectacularly well. And you know, after you look at the basic fundamentals of, we have joint customers, they could benefit, and so on and so forth. There are two things that, from an acquirer side, you often miss. The first is that you have to keep some powder dry, in the sense that if I had, let's say, $200 million budget to get into a new area, if I spent all of that on acquisition cost, then I don't leave myself enough money to be able to work that team and integrate them in, and incentivize the sales force to be able to carry a new product for the first several months or quarters. And it's always advisable to have maybe 20 to 25% of your budget as dry powder that you use after the acquisition to invest into it and to make it more successful. That's that's one. And the second thing that sometimes doesn't work out is the culture of the team you're acquiring. And it is, you will hear people talk about, we've got to find somebody who is a good cultural match. And sometimes good cultural match is not the right thing. For example, at Citrix, this company had been around for 30 years. We, even in 2016, 2017, we weren't using Git for our source code control. We were using some other old-fashioned proprietary software to do that. Our engineering practices were still fairly old-fashioned and waterfall-like, and we hadn't embraced agile as much as one would expect a company of our size to have done. And so sometimes when you acquire a new company, it is also an opportunity for what I call a reverse acquisition, in the sense that you are acquiring a smaller team, but if you work together and if you are kind of open to the infusion of new ideas, that small team can sometimes multiply and grow exponentially in terms of its ability to influence culture and practice at the bigger company. And so you have to be open to that and not kind of get into cultural clashes and always trying to find somebody who looks and feels just like you are.
You mentioned this dry powder and keeping some. Is that what we often see where a company will get acquired and they'll completely gut that other company, that they just didn't leave enough for the other company? Or was that the plan all along?
Uh, Usually, when you acquire a company, depending on the size of the company, of course, if you're simply acquiring a team, then you want to retain most of the team. If you're acquiring a business which has already been executing and has its own financing department and its own sales department and so on, there are some synergies that are built in, and synergies is like a glorified word for saying that there will be some things that will be redundant and you would cut them. For example, you don't need two CFOs, but you acquired one of them, so typically there are some functions that get eliminated in that process. The sales team is, especially one that is productive, is pure gold. And you almost never eliminate that, because these are the guys who know how to sell the product you just acquired. And if anything, you want to be able to replicate their successes and have them be the mentors of your sales team. Right? So those people typically stay. What I meant by dry powder was, sometimes you would have a CFO who says, I have announced to the street that I am going to take a 21 basis points of dilution as part of this acquisition. And now the next time you want to do something with it, you want to create a spiff, for example, for the sales, and say, hey, this is a new product. We want to have every one of our customers try it, but the spiff is going to show up on the balance sheet as maybe another basis point of dilution. Then sometimes these budgets get tight, and you are not able to do the right thing to make that acquisition thrive. And ultimately, the acquisition is measured by its ability to produce additional revenue. And if it doesn't thrive and we are not able to fund the activities of that startup after we have acquired it, then we have basically thrown away good money and without having to get the returns.
No, that's really important. So let's go further back in your career and talk about the early days of Java. So from your LinkedIn profile, I saw you were there working on at Sun in 1997. I started
Mhm.
working with Java in 1996, which is kind of crazy
Wow.
to think about. Uh,
Yes.
do you see any parallels between that time in Java and now?
Yeah, man, that's an excellent question. There are a surprising number of parallels, or uncanny number of them. The So when I got into Java, I I was on the server side of Java, and in those days, as you remember, Java applets and Java running in the browser is where Java first built its name. It's like write once, run everywhere, and it would run in the browser and so forth. But then it was becoming clear around that time that people wanted to have online applications. And this idea that I would have an online presence and I could do e-commerce online, or I could have a brokerage online, or I could have other functions that could be delivered over the web. The concept was just starting. There was a gold rush where every large company wanted to do something in that area. And the kind of things people were doing, I remember if you logged into E-Trade in those days, the URL would say etrade.dll. And if you logged into eBay, it would say ebay.pl. Like that script was written in Perl. And there were plenty of others who were generating HTML out of shell scripts. And when Java 2, the J2EE, which is Java 2 Enterprise Edition, we started standardizing some of the ways in which you could build applications or online applications and build them in Java. So the idea of an application server, the idea of Java server pages, which is the first thing that I worked on when I was part of J2E, was the spec for Java server pages. I remember Microsoft had active server pages in those days, and they had announced ActiveX, I- if I remember correctly, or something like that. And Java server pages was a more rational, more well thought out, something with a well-defined language and grammar ki- ki- kind of way of generating HTML and mixing HTML and Java together. So that's where I started, but it was very clear that people uh, weren't sure of building these applications, not just on the front end, as in the Java server pages, but also in terms of how do you manage your data. If your data is an Oracle database or MySQL or something, how do I get the data? How do I interact with the data? How do I fill forms? How do I bind data to tables and so forth? And so we created a number of different standards or proposals. And I had a first-hand view at how you work in a standardized standards body and get multiple different vendors to collaborate towards a common standard that helps the industry as a whole, but also most importantly helps the users of that product. Before you knew it, we had about 20 different APIs specifications, each one of them about 50 pages with lots of rationale and thinking behind it. And now we had a different sort of problem. And the problem now was that people looked at these different services or APIs that J2E could provide, but nobody knew how these things fit together, right? And people didn't have the time or the patience and sometimes not the skill to be able to work it out for themselves that, hey, I need to use an enterprise Java bean over here and a session Java bean over there. And what do I need to do if I have to scale out my server farm and so on? So with the blueprints in J2E, which is the thing that I was one of the architects for, we created a set of guidelines or blueprints that showed people how you put these things together. The reason I am talking in so much detail about something that happened 25 years ago is because we see something very similar happening now. What's happened is that, the for the last 10 years, you have been hearing about the word digital transformation. And that means that, all of my assets and so on should all have a digital counterpart. I should have my information, my processes, my technology, everything represented digitally. For the last, for the best part, this has already happened to a great deal in most of the companies that we interact with today. So their assets are digital, The data is digital. Their interactions with their customers are digital. The events are coming in digitally, right? So they have managed to do that. What has not happened is that people haven't yet seen the great big aha of now that I have everything digital, some magic was supposed to happen. The company was supposed to gain a competitive edge and supposed to do a lot better than competitors who didn't go digital. That part of it is going through some disillusionment right now. And the reason that disillusionment is happening is because the ability of these companies to make sense of all of the data that became digital is fairly limited. So this time around in 2023, the gold rush is in being able to take the large amounts of data that you are collecting or have the ability to collect every day and be able to make sense of it while the data is still fresh. And turns out that the sooner or quicker you can make sense of the data, the more value you can extract from that data. And that gold rush you see all around everywhere. People are building pipelines. You might hear it in the form of ETL. ETL at its very basic level is a pipeline. You might hear it in the form of streaming applications, payment processing, fraud analytics. All of these different use cases that you hear about, they are all attempts to take the data, which is a resource that you have now amassed, and be able to extract insight from it. Every company that I have talked to, and I've talked to about 300 of them over the last 3-4 years, has got multiple and sometimes dozens of projects that are in the queue to be built or developed, that are going to analyze data that they are collecting, that are going to produce insights from it, either security insights or customer insights or sales insights or product management insights, and so on and so forth. And this is the new gold rush. The companies that are able to accomplish harnessing of this data successfully are going to have a distinct competitive edge over the ones who are slow or lack the resources to be able to pull it.
Yeah, your experience corresponds with mine. I think that there's two issues in the industry. One is technical, as you mentioned, and the other is people. And I think that the two go hand in hand. Is that you have the wrong people trying to use the wrong technologies, and it's hard to sort out which is which or which is worse. And it's really concerning to me because as an industry, we're not generating the value that we should be. We're actually generating relatively low amounts of value relative to spend. And that's really concerning because eventually there's a party that stops. And I've been worried about this for a while. So let's stop this. let's not have this happen. Is you were there for the .com bust, and you don't want to bust like that. That's not fun. It's not fun at all.
Mm-hmm.
Well, let's go forward in time to your time at Citrix. So Citrix was the company that you were at right before you started Grainite. So you have this pattern of being early. I noticed in your resume, you were early in Java, you were early in the cloud at Citrix. What made the cloud so interesting to you?
Yeah, it's an interesting story. So Citrix, when I got into Citrix, we had acquired another company that used to build a product called NetScaler. NetScaler is a load balancer. That product is still there as part of Citrix's product portfolio. It's a load balancer. It's the load balancer that at one point of time, if you interacted with any website on the internet at all, there was a 75% chance that your packets came to you through a NetScaler. So it all of the large web properties, and you can imagine which ones, but they were all scaled or built with the NetScaler at their back. And as time passed by, so these all companies that were previously building web applications slowly started building the cloud. In fact, if you look at the three big clouds today, at one point there was a NetScaler serving a lot of the content behind that. But it turns out that we, as NetScaler, we saw the cloud being born and the cloud gaining traction and the cloud growing, except that we felt that the cloud is something that other people do, and NetScaler itself would not need to do it. And then one day came where we were talking to one of our largest customers. And he says, this NetScaler that you shipped to me as a 2U appliance, that I was very proud of, by the way, because we could push 300 gigabits per second through a 2U appliance. And this person who was an advisor to us as well, he says, this NetScaler that you shipped to me as a 2U appliance, it's like a big boulder in my cloud. I can't move it. I can't provision it with a CLI. It's just like it's a rock that is weighing down that entire cloud. And that's when the light bulb went on. And we said, you know, even though we have had this seat at the table or at the front of the table to look at the growth of the cloud, we haven't really thought of how our business would run in the cloud. And from that day onwards, we started rethinking the cloud, rethinking our relationship to the cloud. And we now have Citrix has almost all of its product delivered in the cloud.
So thinking about fast forwarding to now, do you think there's something missing in the cloud now?
Yeah, that's an interesting question, and look, the way I think of the cloud is it's gone through a few turns as cloud. In the early days of cloud, we used to have these debates about infrastructure as a service versus platform as a service versus software as a service. And turns out that platform as a service kind of has declined or in fashion, and infrastructure as a service is the way most people think of the cloud now. And then to the extent that they need something cooked, they think of SaaS services to cook it with. Now, in the middle, the gap has been filled by what I called aggregated platform services. So if you look at all of the services from Amazon that are not just storage and compute, these are things like Kinesis, for example, on the streaming side, or DynamoDB. These are individual point services that are disaggregated from each other. And it's like, hey, here is a bouquet of services that you, Mr. Customer, can use, and you can put these together, stitch them together, whichever way you see fit. And in the menu of options that we have, I feel like the thing to your question of what is missing is that we have some excellent low-level options. We have got some disaggregated platform services that are slightly higher level than that. And then at the other extreme, we have got SaaS services which are completely fully cooked. And you please leave your imagination behind and use my SaaS service to do whatever it is that you're doing. Makes a lot of sense in many cases, but doesn't make sense in some cases. The gap I see is something that is more cooked than the disaggregated platform services, but still sufficiently flexible so that you are not all the way in the world of SaaS and beholden to precisely the features that the SaaS provider has built. Because SaaS is an equalizer, and companies that are trying to build differentiators don't necessarily want to adopt SaaS as a means of differentiating. On the other hand, to build a differentiator today by stitching together all of these different services is incredibly difficult as well. So I wonder if there is something in the middle.
Well, it turns out that you've made an incredible lead-in of we've got these disaggregated services. What do we do about that? And that leads us to basically the core idea behind Grainite. So let's start whiteboarding out. And we've been talking for a bit. Would you mind diagramming out and whiteboarding out what is Grainite?
Yeah, so thanks for that. Grainite, the way I think of Grainite is it's a converged streaming database. And we got to talk about what does it mean, each of these three words. And, at the outset, when I say converged streaming database, it's like this guy knows how to use ChatGPT. Right? But
Yeah.
there is more to it. And I'll talk about what are the things that we have converged and why do we call it a streaming database. And it turns out that no matter what sort of data analysis or data processing pipeline you build, you are going to use three different things. The first block, I am going to call that ingest. Then there's going to be a second block that we can call process. And then a third block that we are going to call record. Okay, so On the ingest, you can imagine that events are coming in. You have got some sort of processing tier behind it, and you don't want to miss out on these events. Typically, the person producing an event, like a web browser or an application, has nowhere to put that event if you were not available to record that event or to ingest it. And so the ingest tier has this burden on it that it needs to act like a buffer and be able to absorb the events as they're coming in at whatever rate they come in. And typically you would use Kafka is the preeminent product that everybody thinks of first. And so you use the Kafka to ingest these events. Now I've got these events, I can look at them at my leisure. I can I can read them like a file if I wanted, or I can process them as they come in. And that gets you to the processing tier, which is going to have to make sense of these events. So in that processing tier, you would have code that you have written in one of a variety of different languages. You would use something like a Flink, for example, or before Flink, people used to use Spark to be able to process these events. And then once you process these events, typically what happens, especially if you're doing anything that's beyond the prototypical word count example that everybody uses to describe this, if you're doing something meaningful, the processing of the event is not done in isolation. For example, if I received a payment as an event, I need to know how much amount was in the, how much balance was in the account that the payment is being withdrawn from. So I need to pull up some state. I need to process this event in the context of that state. If let's say the event was a location update for a user, I might want to pull up information about that user and see what that location update means in the context of that user. It could mean that they have walked to the nearby Starbucks, or it could mean that they have flown to a different country. And what I would do in both cases would be very different. And the only way I would know which one is if I had previous context about this user. So I'm going to pull that context before I process the event. So I'm going to draw a database here, and you pull that context, you feed the event from here, and then once you have done processing that event, typically you would want to write something back or record the effects of your event back into the database. So you would say, okay, so I have received this new event. As a result, the new balance of this user is this value, or as a result, the new location of this user is this. Or if this user is a car driver and I was trying to track whether they are speeding or whether they are driving riskily, I would maybe record that, hey, based on this event and the user's history, I think that their new risk score, or how fast or how dangerously they are driving on the road, is this new value. So I got to go do a recording into the database as well. And this is something that you do for every event that you process, right? So this is a prototypical event processing pipeline. Turns out that this pipeline is full of a lot of gotchas. And I'm not even drawing the more complex versions of this pipeline yet. But I built a pipeline like this, like I was saying, for Citrix. It took us a long time to build it. And I had something almost exactly like this drawn on a paper napkin even before I announced that product, right? I was like, how hard can this be? This should be fairly easy to accomplish. Each one of these things seems fairly tractable. But turns out that there are dangers in this, and the dangers are one in the building of it, and second is in the operations of it. Let me start from the operations first, because that's the part where I still have some scar tissue from. And on the operations side, you build a pipeline like this and you try to scale it. Your team has just come back. The architect that you hired 9 months ago, they have built their first pipeline. And you ask them, hey, so you have built this pipeline. I'm planning to scale it to about 10x the load that we previously expected. What do I need to do? Turns out that the answer, and that's the answer I got, and that's the answer that invariably most other people that I have talked to get, that, oh, well, we didn't think of a 10x scale, even though each of these components is supposed to be like a pizza box, and then you add more pizza boxes and life is good. But for that, we are going to have to rethink the architecture. The half, so scale is not automatic. The next thing is the half-life of this technology. Half-life of this technology that you use to build the pipeline is 2 years. This means that if you built it with Spark, the new kids are telling you that, hey, man, you should have used Flink. If you built it with Flink, they are telling you should have used something else, like maybe Materialize or something, right? If you built it with Materialize, you are yet to find out what the next thing is going to be. So and finding
And
people
that
or
thing's going to be
expertise
written
who,
in Rust, just so that
yeah,
everybody knows.
yes. So, uh, finding people who who have experience having built one of these things before is incredibly difficult. So what we were able to muster, for example, at Citrix, we were able to find people who were experts at Kafka. We found somebody who was expert at Spark, found some people who, understood graph databases that we were planning to use. But we didn't know anybody who had built a pipeline like this before. So then on the operations side, the first question I asked them when we went to production is, hey, these things are going to fail like they always do. And when that happens, what am I looking at in terms of RTO and RPO? Now, this team of 50 people who had built this thing over 9 months, they couldn't answer that question. And it wasn't that, they didn't have an idea. It wasn't, they didn't know whether it was a day or it was a hour. That's how much the gap was.
Well, define
And I
RTO and
will go on to,
RPO just so we have that for people.
yeah, I think that, yeah, RTO is the recovery time objective. It's like if this thing all went south, then how long before I can start offering service again? And then RPO is that if I lost some data, how much data am I talking about having lost if this whole thing went down? So clearly you don't want to lose any data, but in practice, you are able to tolerate a little bit of data loss. It's like that you get your risk analysis department involved, the CFO adds a risk term to the balance sheet, and then life goes on. So you can work with non-zero RPOs. In fact, most of this pipeline, I don't know of any pipeline so far that I have looked at that has a zero RPO. But so, but typically, you want to know if a node or two were to fail or if a region were to crash, is it like 5 minutes later that the service will be back up? Because remember, we are talking about intercepting a system call on the user's laptop and not letting that call proceed until we hear an answer here. And so to be able to do something like that, I don't want the service to be like a 3 nines or 2 nines or 3.5 nines. If it goes down, I want to know it has gone down. I want to know when it will come back up. And turns out that because of the different numbers of moving parts that we were using, there wasn't a well-formed answer to that simple question. On the ingest side, sure, we were using Kafka, but there was a number of shards that was a question mark. There was
Partition
lag
number of
that
partitions.
a number of partitions, I guess the Kafka is called it. So let me change that. Yeah, so number of partitions. The system is very sensitive to how many you provision and how you change that. On the Flink and Spark side, it turns out that it wasn't just Flink, and by the way, on the Kafka side, there was also Zookeeper. Like every one of these blocks has got like a main product and then a sidekick, right? So it's like a comedy movie where there's the hero, and then there is one guy for comic relief. So on the Kafka side, you have got Zookeeper, and you got to make sure that your Zookeeper and Kafka agree with each other on what's the current notion of membership and partition and consensus, and that's tricky business. On the processing side, you have Flink and Spark, but you need a scratchpad. Scratchpad database is needed. And you are going to checkpoint into the Scratchpad database. And then from time to time, if the processing were to crash, then you would restore from the checkpoint and continue from there on. And the one that lots of people use is RocksDB. RocksDB, by the way, was the author of RocksDB was one of the guys that I used to do my grad school projects with at Wisconsin. So I know this guy very well and have benefited from his advice a few times as well. But yeah, so you put a RocksDB on the processing side. Now you are in the business of figuring out how to recover a fallen RocksDB instance. And especially If I am taking snapshots every hour, I'm going to have to redo processing for the last hour. If I am taking snapshots every 15 minutes, I've got to redo processing for the last 15 minutes. If I am taking snapshots every minute, then my RocksDB is going to permanently crash. Right. So there is no good answer for how frequently I need to take this snapshot. And then finally on the record side, where you have a database, and so you like what could be wrong with the database. Turns out that most databases are not designed to be able to produce or consume or like read or write data at the rate of your event stream. So you are going to add like a cache here, and let's say just for naming names, let's say you added a Redis here. And when you first add it, it's a pleasant surprise because everything is working so much more smoother now. But when that thing goes down, it's not as if the pipeline is going to keep on working, but maybe just a little bit slower. Once that thing goes down, that pipeline is going to stop working. It's like the KPIs of the pipeline are going to go beyond unacceptable and probably cause a cascading failure somewhere or the other in the system. Right. So now I have got 6 products on the slide, and figuring out when I do a failover. Let's say that the region is down, I am failing it over. Just if you consider a simple example where each of these products, let's say, is its own cluster, and being its own cluster, it has its own opinion or its own mind about when it considers a region to be down. And if it did that, then what would happen is that your Kafka has failed over to US West from US East, but your Spark hasn't, or the processing job, the cluster that's doing processing hasn't. And your database has maybe moved over, or maybe the cache has moved over, but the database hasn't. So that doesn't work. So you're going to need to write a bunch of glue code just to convince all of these products to kind of behave in the same modality when they see the same thing happening on their environment. So I'm going to call that fail over /HA, which is like a click down on the RTO thing. And then sometimes you can make incremental restores and other times you cannot. And so the RTO question in particular is question mark, because RTO could sometimes be like 3 seconds. Sometimes it could be 5 minutes. Sometimes it could be 12 hours. And of these, really, the more you start relying on these pipelines and the more mission critical they become, the more you are looking towards something which has an RTO of 3 seconds as opposed to 12 hours. And I was talking to a very large logistics company, probably ships half of the world's packages, or at least half of the United States packages. And they had built a pipeline like this, and their RTO was 12 hours, which they only found out after they had built it. And so turns out that, if one of the regions in the cloud goes down, it is 12 hours later that they can tell you whether your package was even delivered or whether it's been put on a truck, or which truck to even put it on. Right. So these are the kinds of problems on the operations side of a contraption like this. On the developer side, which is, remember, we are targeting enterprise developers. These guys wake up in the morning. They are experts at the business problem. They are experts at the domain that they are working in. They understand the rules, they understand the regulations, they understand the business. They are not experts at distributed systems, and they shouldn't be. I faced the exact same pattern when I started my second company, Terros, which was an application firewall. When I talked to developers, and they were experts in their domain, but they were not experts in security. And they were like, I woke up this morning because I wanted to make this inventory workflow work. I didn't wake up this morning to figure out whether SQL injection is going to ruin my day. Right. So the same kind of thing is happening here, is that I have got these developers, they understand their business, they don't understand and they don't want to understand distributed systems. But because I have got 6 distributed systems in the mix, they have no choice but to understand distributed systems. They have no choice but to plan for the contingency of when the system only half fails, when there is a split brain, when something is being retried, when something that they wrote is not idempotent, when they acquired a lock and then crashed while holding a durable lock. All of these things that have nothing to do with their domain. Like if my domain is to build a ride-sharing application, or my domain is to build the best user experience for a coffee shop, or my domain is to build payment processing for a bank, none of the things I talked about earlier has anything to do with the domain. The developer rightfully complains that they shouldn't have to understand these things, except that to make this pipeline work, you have to understand those things, because it is very likely that your processing will have to be restarted, and then you would have duplicates, and then you would need idempotency to get rid of those duplicates. And if you went down the path of distributed transactions and locking, then you would have to work with lock recovery, right? So there are all of these kind of gotchas that come in the moment you realize that the system you're building is a conflagration of distributed systems put together. And so that's the building or coding side of it, and the hazards there. And now finally coming back to the question that you asked in the beginning, which is what is Grainite, and I said it's a converged streaming database. What we do is that we take these three things and we converge them into a single system that is just a single cluster that auto scales, and that internally contains all of these three functions built into one. And I'll talk about why we use the word converged, as opposed to, for example, we could have said integrated, but we didn't. And what does it mean to be converged? And why or how does converging these things together solve some of the problems that I just outlined?
So I just want to do a quick +1 on a lot of this. Although a vendor may tell you, hey, Kafka can have an RTO of minutes. Not necessarily. Not necessarily. And then you brought up another important part of the level of integration between these two clusters of a Spark cluster and a Kafka cluster. If one could be down and one could think it's up, and they could be reaching across to a completely different cluster that's now being replicated to in a different region, and now you've got an increase in latency and you may not know why. There's a lot to this. This is by no means an easy problem. And so I just want to call out to the people who are curling up in a ball right now thinking about this because they're living this. There are solutions, and those of you who are thinking, what are they talking about? This is all real. don't let the hand waving people tell you that this is not real, that these are real issues that you will have to deal with. So yes, how about let's go to the whiteboard 2, and let's talk and go deep into how Grainite works.
Yeah, so let's talk about it. So I said that we are converged, so I'll start there and say, what does it mean to be converged? So now we have got ingest, process, and record. We have got all of this in the same cluster. And so, one could say, okay, so you got it in the same cluster. I get that. But how does it solve the problems that you were talking about? Do I not have to do retries? Does this thing not crash like it's running in the cloud? What do you mean it will not crash? Surely it will crash. And how does RPO and RTO improve? How do I operate this thing more efficiently? And so on. So my answer to that is that if you look at the previous picture, the root of the evil, the big problem there was that there are two safety constructs that databases use. And the first construct is called consensus. And the second one is called journal, right? A journal is something that you write on your disk, right? So a single node, it's a single node concern. The node will, whenever it receives an action or something to do or something that will change its state, it will first note it down in a journal. It's like a logbook, right?
Write-ahead log is probably what people have heard, for example, in Kafka or others.
The Kafka guys call this a log, right? And so once you write it into the journal, then as far as the user is concerned who submitted that action, their job is done. They're like, it's written in the journal, now it's become durable. But once it becomes durable, it has not yet become readable, in the sense that the journal still's got to be processed, and the action that you took has to be reflected or quote unquote materialized into the database so that you can now read and query and see the results of your action. Right? So the journal is the first such construct. And the beautiful property of the journal is that if I wanted 5 things to all happen at once, like to all happen either atomically, as in either all 5 should happen or none of the 5 should happen, the way that's accomplished is by writing it into a journal as a single entry, because the journal is atomic on entries, and I can write my 5 things that I want to do together as one entry, and then it will be atomic. The consensus is the distributed analog of the journal, and what it says is that I have got all these different nodes, they're all writing their own journals, but they all will not necessarily agree on what was the order in which actions were taken. So if the order was supposed to be ABC, the first node might remember it as ABC, but while the second node might remember as ACB, like in a different order. And the job of the consensus is to get these different nodes to agree on what was the order in which they were going to do things. And why is it that different nodes are doing the same thing? It's because of redundancy and durability and being able to when you write things in multiple places, when you do things in multiple places, the same thing, then you have got the redundancy which leads to higher availability. Otherwise, if you build a system where everything is happening only in one place, then the mere failure of a single node is going to cause you to lose processing, it's going to cause you to lose data, and that nobody wants. So typically, the kind of the rule of the thumb is that you write your results or you write your actions in at least 3 different places. And ideally, those 3 places would be fate isolated, as in they wouldn't all fail at once. So that's the job of consensus, is to put things in order and make sure that these different places where you write things are all able to keep track of the order in which they are applying these changes. Collectively, this is in the broad branch of what is known as state machine replication, or I will just call it replicated state machine. So the people call this a replicated state machine because as long as I can guarantee that different nodes will see things in the same order and they always do the same thing when they see a given action, then hopefully these nodes will stay in sync and do the same thing over. So this part is well understood. Turns out that in the previous diagram, the ingest, process, and record, each of those components had their own replicated state machine. So while each component was guarding and safeguarding its own, nobody was responsible for consistency across components, right? So I have these beautiful constructs. They have been studied for 20 years in the world of distributed system. Every one of the components that you have recruited already is taking advantage of these constructs, but the user of the system is still at the mercy of, of Murphy's law, as in the bad things are going to happen to this user because there are cracks through which there are cracks between these through which these guarantees were slipping through. What we have done very simply is we have wrapped the 3 components into a distributed consensus on top and a distributed journal on the bottom. So we are saying it's still going to be ingest, process, and record because that's the fundamental thing that you're trying to accomplish. But instead of the ingest having its own idea of consensus and journal, and the process having its own idea, and the record having its own idea, how about if we excise the idea of consensus from each of these components, and we excise the idea of journal from each of these components, and then we unify or converge these 2 concepts across the 3 components. Turns out that when I first started discussing this idea, and in fact, this is a great time for me to introduce Ashish, who is our co-founder. And if you have looked at, you have heard my background in the past. This guy has been building networking stuff for the last 15 years. What does he know about database? Turns out that my partner in crime here is Ashish. Ashish used to run all of the databases for Google, right? So everything from Bigtable to Spanner and anything in between, like Cloud Store and Megastore and all of the other properties that have to do with databases. Those were all things that Ashish was directly involved in. He used to manage teams for all of those, grew up on the technology side as well. So I and we kind of debated these ideas before we had started Granite. And we're like, there's a problem to be solved here, Ashish. And I am thinking, could we separate these things out? And Ashish is like, yeah, that's a good idea. And in fact, he had tried doing something like this as part of Spanner, and finally concluded that it was too difficult to do on an existing code base. Turns out that once you have built something like a distributed database or a distributed queue, as in think of Kafka in this case, there are so many assumptions that go into tightly integrating, sometimes for performance and sometimes for correctness. You so tightly interweave the journal and the consensus into the core of your widget that it is impossible to take that out of existing code. So when I first started Granite, I looked at maybe 35 different open source components because I'm like, the year is 2019. Nobody builds a database from scratch in 2019 because surely there are all these open source components out there that we could start from. And turns out that we couldn't start from any of them. The reason we couldn't start from any of them is because we wanted to unify or converge the idea of consensus and journal across them. This is a really difficult problem. The more closer somebody is to the engineering behind a database or behind a queue, the more incredulous they are when I tell them that this is what we are doing. Right. So this is a fairly tall order, fairly difficult problem to solve. But it took us 4 years to solve it, and we finally are at a point where we have managed to take the consensus and the journal out of each of these three components. As a trade-off, each of these three components is completely built from scratch in our work. We are not using Kafka for the ingest. We are not using RocksDB for the record. These are homegrown components, and I will talk more about why that's the case beyond just consensus and journal. But some interesting things happen when you take these components out. The first thing that happens is that you get some strong guarantees. And the first strong guarantee is what I call virtual resilience. What I mean by that is that now when an application developer writes code, they simply write code as if this code is running on a node that will never crash. Right? So they get this virtual impression or they get the illusion as if their code is going to run exactly once. The code is going to run exactly once and never crashes. So now they can get out of the business of writing boilerplate code for idempotency, writing boilerplate code for retries, figuring out if their KPIs in terms of latencies from end-to-end latency across the pipeline are going to be impacted if their Flink was recovering a checkpoint at that exact moment. Right? So those issues simply are no longer the developer's concern. From their perspective, things that they write in code will happen exactly once. It's just like you ran the code on your laptop, you ran it, it ran, life is done. Right. So you don't have to worry about things crashing. Now behind the scenes, of course, Granite is a distributed system, consists of multiple nodes. And of course, the network is going to sometimes misbehave and the nodes are sometimes going to crash. And even Granite software is sometimes going to crash or be the culprit behind a crash. So it is a virtual resiliency paradigm, as in these things do crash, but the developer doesn't have to care about it. In their mindset, it's all one. So that's the first thing that happens by combining these things together. The second thing is that performance. I could have gotten these strong guarantees. Okay, I'm here. I could have gotten these strong guarantees by wrapping the previous system that I showed you in what's known as a distributed transaction manager. And then I would have like the similar strong virtual resiliency type of guarantees where things will happen exactly once and so on. Turns out that those systems are extremely slow. Like you would maybe be lucky to do even 100 events per second in a system like that if it was replicated 3 ways. In Granite, the performance comes for free because we have unified the journal and we have unified the consensus. So said another way, for the cost of a non-distributed transaction, we are able to provide strong guarantees that otherwise only a distributed transaction coordinator would be able to provide. Right, and so performance is the second thing. The third thing, which is okay. So first is atomicity and performance. The second thing is that when you have got 6 different consensuses and 6 different journals, each one of which wants to write things in triplicate. Remember, if you don't write it in triplicate, then there is a non-zero chance that you would lose the data. So each one of the components wants to write it in 3 places, and they all have their own journal, which means if you do quick math, you are suffering through a write amplification of 18x. So 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 we take that 18x write amplification and we take that down to 3x. 3x is the minimum cost of doing business, right? So because there is only a single consensus and a single journal, in Grainite, we only write things once and we write them thrice, so to make sure that we don't lose it, but we do that act of writing it in triplicate only once. And that's why the system is not fast because we wrote really clever code and we stooped down to C and assembly when we had to. The system is fast because it simply does a lot less work, right? So this reminds me of my first startup where we had built a codec, a video encoding system that was able to run 16 parallel decodes on commodity hardware, while in those days competitive decoders could only run one. And the question was, how come what have you done in your code to make it so fast? And the answer was, we hadn't done so much in the code as we had done in the algorithm. And so it's the same answer here. We are using algorithms that are intrinsically more resource efficient. Now, we have also rebuilt the system in C++. We are a team of database builders. The kind of team that we have assembled here, we have only built 5 9 systems in the past. Like if you look at Kafka, Kafka is 3.5 nines. If you look at RocksDB, it doesn't make sense to talk about nines in RocksDB, but Flink is 3.5 nines. If you look at DynamoDB, DynamoDB is 3.5 nines, unless you use their global version, which is very, very slow. Conversely, the team that we have put together, we have only, NetScaler was a 5 nines, 5.5 nines system because it was a load balancer. It had to outlive every other thing that you put behind it. Uptime on a NetScaler was you routinely measured in years, which was a bad thing for us because we couldn't upgrade the software fast enough. But so both Ashish and I and the team we have put together is a 5 nines kind of system building team. We are a team of database builders. So we have written this thing in C++. Yes, not Rust, but maybe one day we would move to Rust as well, but not on the horizon anytime soon. So it is built for performance, both algorithmically and code wise. But it is really the big win here is because of the algorithm here. So that's the second thing that happens, and then there is a third thing that happens, which I call no head of line blocking. And let me talk a little more about that. When you have a unified consensus and a unified journal, and you are writing it from scratch, what we realized is that one of the things that happens in partitioned systems, and I remember from my previous life, is that we had people who fussed about partitions quite a bit. Like they would be thinking about how many partitions are in Kafka, how many are in the Spark behind it. Are they multiples of each other? Do I need to increase one here? Do I need to decrease one there? Is one of the partitions lagging more than the other partitions? Like, so their life revolved around the idea of partition. And the only reason their life revolved around the idea of partition wasn't because they had written special code for partitions. It was because the underlying systems had exposed this notion of partition as the unit of parallelism to them, right? So in most of the existing pipelines that you build, I would go on a limb and say in all of them, the unit of parallelism is a partition. If you have more partitions, you can have more parallelism. If you have less partitions, you will have less parallelism. Turns out that Ashish and I have the same first initial, and so we always hash to the same partition, which means either Ashish gets to go first or I get to go first. But what if we both want to go in parallel? Right? What if we want to break down this artificial restriction that a partition creates, which is that everything in the partition must be processed sequentially? So when we were creating this consensus and journal algorithm, We introduced this consensus is built around Paxos like every other consensus is, but it's not like any Paxos that you have seen so far. And the journal is also different in many ways. And these things are designed so that even things that fall in the same partition can make progress in parallel. We call that idea hyperqueues. So you can think in the world of Grainite that every row of the database has its own little FIFO or queue built into it. And all of these queues can make progress in parallel. So if you had a million rows, your cardinality of your data set was a million, then you can have million micro queues, and each one of these queues will make progress in parallel. If you had a billion, then you would have a billion micro queues, and they will all make progress in parallel. No one is blocked because of somebody else's work. So in Ashish's and my example, if he had submitted some work into Grainite and I had submitted some work into Grainite, even if we happened to be in the same quote unquote partition, we would be able to make parallel progress. So that's the idea of hyperqueues. We we took the idea of queue that Kafka has popularized and we turned it into hyperqueues. On the processing side, then something interesting happened. So now you're saying, okay, so now things can go in parallel and, I can reorder things. I can move Ashish's work in front of my work or my work in front of his work. Don't have to worry about the partition semantics when I'm doing that. But how do I take advantage of this new freedom that I have earned? The way we take advantage of that in Grainite is through what we call data scheduled compute. Data scheduled compute. What data scheduled compute does is that now that I have got, let's say that I have got work from Ashish and I've got work from Abhishek, and I'm trying to decide which one of these two should I send on. I'm going to prioritize the work for which I have the data in memory. Right? So if Ashish's work, I have the related data in memory, I would simply schedule that first. And in general, I only ever schedule compute if we have already got the data for that particular compute in hand, as in memory. As a result, because of data scheduled compute in Grainite, like the processing in Grainite, it would be hard pressed to even run for a millisecond, right? Because normally compute runs for hundreds of milliseconds because the very first thing that compute does is that it pulls some data and promptly blocks on the database while holding your thread, right? In Grainite, that doesn't happen. In Grainite, by the time we hand you the compute to be scheduled, the data associated with the compute is already being pulled into memory. We take advantage of the hyperqueues to be able to intelligently schedule this, and that's the second innovation. This one is particularly dear to me because when I was at Citrix and I was running the load balancing side of things, I was growing kind of dissatisfied with the way load balancer works. Because if you think of it like squint your eyes a little bit, a load balancer is trying to find a node that should do the work such that this node is the least utilized node in the system. Like whichever node is got more idle cycles, let's send the work there. So, so one way to rephrase that is that a load balancer solves for compute. And then the load balancer says, compute is my scarce resource. I got to conserve it, watch out very carefully for it, and I'm going to pick the least loaded node and send the work there. Turns out that in these modern applications, and in most applications these days, compute is no longer the scarce resource. Compute is available in abundance in the cloud and at will, as in I can grow it, I can shrink it, I can summon more or less of it fairly quickly, fairly effortlessly, well understood area. And really, the scarce resource is data. What that means is that if the scarce resource is data, then I need to use data as the primary means of deciding what I am going to schedule for compute. Don't use compute and idle time for that. And that's what data scheduled compute is able to unlock. So now I am basically pressing it where it hurts, where, if I don't have the data, what's the point in scheduling the compute? The node may be idle, but that doesn't help me. If I have data scheduled compute, by the time I schedule compute, the data is already there and life is good. And that brings us to the third thing. If you are successful in both of these first two ideas, And so you have hyperqueues, you have data scheduled compute. Now you are seeing a boatload of requests land on the database. Storage engine. So you are now seeing a boatload of requests land on the database. And what would happen is that every database out there, including Spanner, including Bigtable, including DynamoDB, and so on, none of those databases are equipped to serve, let's say, 1,000,000 requests per second if they all came in together. Like I told you that the hyperqueues have unlocked my parallelism from like 12 shards to 1,000,000 ways in parallel. So now if all of these guys wanted their data hydrated all at once, and maybe not 1,000,000 per second, even like 10,000 per second, the databases are not equipped to deliver that data at that rate. And so what that amounts to is that it amounts to consumer lag. Your database has now become the bottleneck, and as a result, the data is going to sit in the queues. They may be hyper queues, but it's going to sit there and not get worked on because you simply don't have a database that can push this data. Now, this is not a problem. This is not a fault of the underlying media. Like the storage below the database, these days for $300, I can buy an SSD or an NVMe drive that would give me 1.5 million parallel IOPS. But none of the current databases is able to saturate the read bandwidth of such a disk. So Grainite, even before Grainite was formed, we were ideating a new storage engine whose unique selling proposition, whose unique property would be that it would be able to saturate those 1.5 million IOPS that an NVMe gives you. It would be able to serve results in microseconds as opposed to milliseconds. And it would be able to pair very well with a system that could produce that high a degree of parallelism. So these two will produce high parallelism. And this guy is going to give them the high parallelism that they need. So these are the three components underneath in the technology of how the engine behind Grainite works. There is another way to talk about Grainite, which is how does somebody who is using Grainite experience Grainite? Like if I am that famous application developer that I've been talking about all this while, what does it look like to them?
Well, let's unpack a few of what you talked about because I imagine listeners, if they weren't experiencing this problem, have their eyes glazed over. So I want to unpack some of what you said. And one of the typical things that I see what you talked about with this strong the strong end-to-end guarantee is for money movement. So if you debit somebody's account with 200 and you want to deposit 200 in another account, this is virtually not possible to do with this consensus because one system will do it the negative 200 first and then the positive 200. And so there's a problem to this that if you do this out of order, you can take somebody's account below minimum and then they get charged fees. So that's definitely an issue. And so people may be sitting there thinking, well, I know Kafka has atomicity guarantees. So here we are, we're here in our ingest. Well, guess what? Your atomicity guarantees, your transactions only exist here in Kafka. If you're lucky, you're using a system, maybe Flink or Spark or something like that, that can use those two. But for Kafka, that only exists here. But you don't get atomicity over here with your database. You do not get this end to end. So I really want to make that clear that there's been efforts. People will put some code in place. I've met people. I've talked to people who've done this. It is possible to do this. It is so incredibly brittle to do this, and as you did talk about, the performance on this is terrible. Distributed transactions, distributed out, it is very, very low performance. So you've created this high performance system that because of all this, you are not going to be able to do it. So yes, you can get exactly-ish once in Kafka. but there's a lot of caveats to it, and you probably don't know those caveats of what happens when something dies. So there are some really key parts to this that if you don't understand this right, and you're trying to create a system or you're banging your head against a system, uh, this is often banks dealing with this, or some people will call this an orchestrator pattern. This whole orchestration is something that Grainite can handle well. Of it's trying to reach out and it's trying to do this ingest process and put this into database. That could be a whole problem unto itself. And I've worked with companies doing that. These are hard problems. They're problems that change, and you get a lot of people on them with very little value created relative to what you're trying to do. So hopefully that makes sense. Do you have anything to add there,
Mhm.
Abhishek?
No, I think that's spot on. And since we are unapologetically technical, I am going to say one more thing, which is that sometimes, like you said, sometimes these transactions are workflows because they are actual bona fide different systems, and I want to treat them as different systems. I maybe want to use a saga pattern, right? And I want to run a workflow around it, and have I I would deduct the $200, and then if it goes to, let's say, a different bank, and the different bank says, well, the account you're trying to put the money in, there is no such account, so it was a bad wire, and so I need to now do a compensating transaction and add the $200 back, right? So sometimes the real world is such that there isn't atomicity of the kind that we are striving for here. In those cases, Granite has what we call the law of conservation of messages, and that is like an extension of this atomicity or transactional guarantee. And what that means is that if you send a message, then either that message will be delivered to somebody, or it will be delivered back to you, so that you can say, hey, this message I sent, something happened to it, didn't go, came back to me, it was undeliverable, so I can now run a compensating transaction against it if I wanted. Or it would show up in an error sync. Messages don't just mysteriously disappear inside Granite. It's like, you sent a message, something happened to it, but we don't know what happened. That wouldn't happen with us. This law of conservation of guarantee is very conservation of messages guarantee is very, very difficult to provide in any system that is not converged the way Granite is converged.
Just a little bit ago, I had you pause on something, and that was on the programming API. So I've looked a bit at the API, and I find it really interesting, where there's the manifestation of this architecture that you've done, and that's changed the API side. So could you talk us through that?
Yes, definitely. So we talked about the under the hood of Granite a little bit. Now let's talk about how does a developer, an application developer, actually use the system, and what does it look like to them. And for that, we talked about ingest, we talked about process, we talked about record, and on the ingest side of it, we have something we call topics. And as you can imagine from the name, this is a concept that's very similar to how topics are in something like Kafka. These these are topics. They contain events. The events are ordered by key, and just like in Kafka. And that's what the ingest side is. We have an ingest API that you can use to directly feed data into Granite. We can also pull data from an existing Kafka topic, for example. If you had data already sitting in Kafka, Granite has a built-in mechanism to continuously feed or ingest data from Kafka, and then it becomes available as a topic within Granite. On the record side, we have what we call tables. And as you would imagine, the tables are collections, or they contain rows in them. The Granite data model is a NoSQL style data model. And there are a few twists in the data model, and I'll talk more about that in a moment. But tables in Granite contain grains, just like topics in Granite contain events. And think of a grain for the moment as if it's a row in a big table, or a row in a NoSQL wide column database. And then processing in Granite is code that you write. And under the covers, the code runs within Granite. But let's say we support two languages today, Java and Python. We will add support for more languages shortly, the languages that are JVM based are easy for us to add support for. The other ones like .NET is a popular one. We are looking at adding support for that now. But the API and the programming model is agnostic of the language. I'm going to talk a little bit more about that. So the way to think of it is I'm going to draw that processing block in the center. This is code that you write. The input to this code is an event. So in Grainite, you would define a subscription. And the subscription would say, hey, I have, let's say, an order event. And the order event comes in and it needs to be processed by a table called orders. And so the event comes into the orders topic. It's to be processed by some code that you have bound to process order as a handler. And so this thing that I drew, it's called a handler. So you wrote an action handler. The action handler is going to process this event. The way the mental model for the developer is that an event will come in, your handle event method is going to get called, and you're going to handle that event. Way back when in J2E, these things were very, very similar to that. You used to have requests. The request comes in, the servlet handles the request, produces a response, and life goes on. Here, an event comes in, you process the event. Along with the event, we are going to also provide this guy the context of the event, automatically provided to the event handler. The event handler will run, and the event handler is going to produce mutations back to the database. So the event handler has decided that it wants to update, let's say, the user's location. That's a mutation. It produces that back to the database. And it's going to produce a collection of messages or events that should be sent to other grains, right? So that's, and the fact that it produces the mutations, the fact that it consumed the event, and the fact that it produced these other events. So event input, mutations, and the event's output. These things form an atomic tuple in Grainite, in the sense that these will either all happen or none of them will happen. And that's how we provide the atomicity guarantee to you. But if you look at it from the developer's perspective, their life is very simple. Unlike in the past where you have to write one domain object for your batch processing pipeline running in MapReduce or Spark, another domain object for your stream processing pipeline running in Flink, and then a third domain object for your serving tier, which might be running on top of MongoDB somewhere. In the Grainite world, you create that domain object only once, and the domain object is written right here. And to this domain object, everything, batch processing, which is not something that we advertise, but you could use Grainite for batch processing, stream processing, which is what the bread and butter of this idea is, as well as serving. All three models can take advantage of the same domain object and behaviors that you have coded up. So you write this code exactly once. You don't have to adopt all three on first blush, but you could technically use all three. The event on the left can come in from three different sources. The first source is, of course, you could call an API and directly invoke the event. So I had a function. The function was going to handle an order. I have an order in my hand. I can just invoke the handle order line. So this is the kind of thing that you would do if you were building a serving tier, right? You would simply call the API. The API will produce results, and you would work with those results. The second thing that these things can come in is from topics. So topics are, remember, topics is where events are ingested. So now these events are sitting in a topic, and you have created a subscription from that topic to that table, and events are now going to flow from the topic into the table. We are going to manage, let's say you rewind your topic to last year because you are going through an audit. The auditor has asked a question, and you need to replay or refill. no problem with Grainite because you simply define the topic, and we will be responsible for getting all of that work completed with the maximum amount of parallelism afforded by that workload. You wouldn't have to redefine the number of shards or partitions. You wouldn't have to try to match them with your processing tier. That all happens internally. But that's the other place where events come in. Most commonly, events that we process in Grainite for a stream processing application would be coming in from a topic. And the third thing, place where they could come in, is from other grains. So you wrote a handler, the handler produces these events on the right. These events will then hit a downstream grain. So that's how you build complex event processing with a DAG in the middle, is that you have these events go from one grain to another. And so that's where these events could be coming in from. And then, of course, on the going side, the events could be going to a topic. The events could be going external, like to a Kafka, if you wanted, or a Kinesis, or the events could be going to a handler, some other handler. So with that kind of construct where the developer only sees and only has to worry about writing an event handler, and once they have written that event handler, this event handler is good for batch processing, stream processing, and for serving tier. That that really simplifies the amount of code you have to write. And remember, there is no boilerplate code around locking and idempotency that needs to be written here. So we have found entire applications, like meaningful production grade applications, that people have built in 300 lines of code on Granite
I
by
would
by
I would
following
add
the code.
on two other parts to this, and that is that there's no specific DAG creation where you're having to worry about how this DAG flows into another place. That will form, but it will form just by the way you've laid things out. But another big one, and that is with Kafka, for example, Kafka API, you're 110% responsible for your threads unless you use some other program. So there is no threading over here that you're having to worry about. No parallelism, none of that. That guarantee of end-to-end transactionality really frees up a bunch of error handling. And that error handling code could be pretty significant, especially if, as you say, you're reaching out to an external or you're reaching out to some handler. That can be pretty difficult.
Agreed. Yes.
So you talked about those grains. Now I'm going to try to play devil's advocate and think about what people are asking themselves here, and they're probably saying, "I'll believe it when I see it. I've heard this from other people. Why should I believe you? Why should I believe that you can do a transaction atomically like this?"
That's a good question. I think that is, look, I'll get slightly philosophical, even though it's a technology session. And I would say, as a startup, and we are a young startup, we have been in it for about 4 years. We have got like good investors with deep pockets who have done this kind of work before. But still, a startup has to build two things. The first is product, and the second is reputation, right? And especially for a product that plays in the field of data, and where data and data loss are always the kind of things that plague people's minds when they're thinking about it. From that perspective, we do have a few customers who are trying it out. We have got some who are paying customers as well, but it is still early days for Grainite, right? So it is, I would say that we would have to build that reputation, but we would have to build it in partnership with our customers and the people who try it out. The second part of the answer, though, is that as distributed systems engineers who have built this sort of stuff before, we understand the importance of testing, right? And so you have heard of Jepson, for example. Jepson does distributed tests for other people's products. When we started the company and we were looking at, okay, we are going to build this thing, the first question in our mind, even before we wrote the first line of code, was, this is a big undertaking. How do we plan on testing it? And if I go in front of a customer and I just say, hey, I built 5.9 systems in the past, how do they know that I am building a 5.9 system in the present? Right? How can they trust me? And the only way we can trust ourselves before I go to a customer and say that is through the benefit of testing. It turns out that in the world of distributed systems testing is still a pretty nascent field. We looked and we couldn't find all that many good products that do a great job of distributed systems testing. We have built our own testing harness as a result. It's something that tests the system, puts it through a bunch of different scenarios, including what you would expect in a distributed system where things are failing, the network is being partitioned, the clock has been skewed, like all the common ones, the error injection ones, but also some esoteric hand-coded scenarios that are particularly difficult for a distributed system like ours with the strong guarantees that we provide. And to be honest, it wasn't until about maybe 15 months ago that our testing was it was regularly producing bugs and issues. And we it's one thing to build a distributed system; it's another thing to be confident in what you have built. And so the last maybe 12 to 15 months, we have taken in making sure that the system is hardened to the level where we feel comfortable that it can field your data.
So, what sort of companies would you think that should be interested in Grainite?
Yeah, I think, look, anybody who is building a distributed pipeline with Kafka, for example, or Kinesis, or any of these ingest products, and they are looking to get more and more results in real time, should be interested. I'll give you I'll give you two more constructs. One of them is slightly more self-serving, and then one of them is a more kind of narrower use case of this same paradigm. From Grainite's perspective, like I said, and like you said as well, we are a young company. We are looking to build reputation in addition to product, and what that means is that the ideal partner for Grainite is going to be somebody who has the ability to experiment, who has a problem that they are not able to solve satisfactorily with the existing ways that they are doing it, also has a little bit of experience. Like if somebody has not seen the pain in Kafka, then it is that much harder for us to convince them that Grainite is the right answer for them. We have done that in a couple of cases, but it's difficult. Versus if you have operated Kafka, you have operated a pipeline like this, you have worked with Flink or Spark, and you know where the problems lie, then it is that much easier. And then the final thing I would say is that for the first use case that you think with Grainite, think of something where real time is important to you, but where you have a plan B. Like my motto has always been, both as a startup and as a buyer of technology in the past, that it has to be easy to put the technology in. It has to be easier to kick it out, right? Because nobody wants to stick their neck out for technology that they are only starting to experiment with. And so it's important. We have designed the system in such a way that every time you put us in, it would be fairly easy to take us out if you change your mind. We believe that you wouldn't need to, but you have to have the peace of mind that you can. And you yourself should qualify your use cases in such a way that that statement holds true. So you don't directly build the most mission critical pipeline on top of Grainite on day one, but you build it with something on the side at first, gain the confidence, gain the experience, and then expand from there.
You brought an interesting concept. I talk about one concept similar in my book of the ability to kick out a technology. My friend Ted Malaska, he wrote a section from data teams talking about learning to hate technology, where one of the worst things I saw, or one of the most concerning things I saw in the Kafka community, was this love of Kafka, which meant that they were going to use it for things it was not appropriate for because of this love. Kafka works great for these things, does not work good for these things, but you're going to use it for those bad things and then be surprised when that happens. It sounds like you have a similar philosophy of let's make sure it works, let's build on that. Is that correct?
That's exactly right, yes.
Okay. So you use the word partnership. What do you mean by that? Because normally people say customers or clients. Why is this a partner?
Yeah, I think in the early days of the company, we just like a customer or partner is qualifying us, we are also qualifying them a little bit. And we need people who are well versed in the technology, who can give us good feedback as we build the product and the next version of it and so on, who can provide us with good feedback, tell us what they like, what they didn't like, in what ways it should improve. And so we call these early customers design partners. We really treat them as our partners. Their input is some of the highest priority of input that we get from anywhere, including internally from our own team. And we for being early with Granite, we also have incentives on the sales side that we offer them, so that they so that their time and money is well spent with the company.
That's good. Now, switching on to the roadmap, what excites you about Grainite's roadmap?
I think this is also a good time to talk about the name of the company. In the beginning, our VCs sometimes joke and say, "Hey, you got that name because with the misspelling you were able to get the domain." And there is truth to that. But there is also a rationale behind the name. And the rationale is that we felt that the world of data, everybody has heard this where people say, oh, data has gravity. And so one could say, well, data has gravity and there's nothing you can do about it. Or you could say, yes, data has gravity, but instead of treating data as one big mountain, what if we could treat it as a large collection of small grains? And if you could do that, then sure, it has gravity, but I can still be a lot more agile and I can still do things one grain at a time, what we in the world of Granite we call grain wise. So we do believe that as we get more established and the paradigm that we are popularizing becomes more well trodden, we expect that this idea that data should be thought of as a large collection of grains as opposed to one big mountain is going to take root. And when it does, then the way our technology is built is going to find more and more applicability into the world of data. I almost, one of when I am feeling a little dreamy, I think of us as just like virtualization changed compute, Granite is going to have a similar impact on the world of data.
That's interesting. As we talked about throughout your career, you were pretty early on, so this could be early on in that virtualization of data that we've been hoping for. One thing I've found as I've talked to you is you bring a great deal of technical depth and a great deal of business knowledge. Why did you do that? Why did that? Because your degrees are in computer science, distributed systems, not in business. Well, why did you decide to go so deep into the business as well?
Oh, it's a very interesting question. I think, look, for the longest time, I didn't want to, there's a term that the engineers use, it's called crossing to the dark side. And that's when somebody kind of switches from being purely engineering minded and then more towards the business side. When I first graduated, I was completely at the other extreme. I didn't want to work on anything that had practical utility. Like I was the math guy. I would do theoretical computer science. Sure, I would prove some consensus algorithms and stuff, but I wouldn't want anything like, if it was about abstract triangles or abstract polygons, that would be best. If it had some utility, that wouldn't be so ideal. And so that's where I started. And over the years, I have seen, my first startup was around a mathematical formula. Like that company, that Kodak that we did, it was a pure innovation in the world of algorithms. My second startup was around security. There was some math behind that as well, but it was more around applications. And then as I have matured myself, I have realized that technology exists to serve a human need. And in that sense, building technology like the one that we are building now serves a very real need in the world of data. And that's that's exciting in its own right. Like when you can build something and then you see that there's a need and other people like you who are practitioners in that space would hold that need, and that need would drive its adoption. That's what's caused me to kind of move a little more into the world of business. I am still very squarely grounded on the engineering side. So I am like a engineering practitioner that kind of masquerades as a mouthpiece from time to time.
Yeah, if people didn't know, there's imposter syndrome on both places. I still feel the same. I'm a software engineer who plays at business, and I'm a software engineer who
Mhm.
plays at interviewing people. I look at
Mhm.
the people and I say, "Oh, look at how much better they are at this than I am." Well, you can get better, but you have to practice at doing it, and I find that journey interesting, and I would encourage people who are seeing Abhishek, think of it as a journey. It's not that he was this good from the very beginning, as he mentions. It was a journey. It was a lot of effort. I have one last question for you. Why did you decide to found another company?
Yeah, I think this is goes back to the technological roots. So there is like a tactical reason which I described earlier, which is that I was working trying to solve this problem for Citrix, and it was a dissatisfactory feeling because I felt after 3.5 years that we solved the problem, but it wasn't something that anybody else could do. And then when I found Ashish and we brainstormed it, it was clear that Ashish had solved the problem too, and at Google scale, not like the Google personalization engine, which is basically holds the privacy and related information for all of the globe's users. That was another project that Ashish was running, right? So he had clearly solved the streaming data problem, but he hadn't solved it in a way that was democratizable either, because in his team, he had the most senior people in the world of distributed systems from around the world, babysitting and building that pipeline for him. And that's not something that a Walmart or a non-technology oriented company could easily replicate. So, so that's the tactical reason. There is got to be also a passion when you start something new, and especially for me towards maybe the latter part of my career that I am in. And that passion comes from this idea that I love when I talk about Grainite. Remember the diagram that I drew where I said, hey, we have unified consensus and journal. When I talk about that diagram with people who have built databases before, I can see the gears turn in their head. And they're like, either this guy is not telling the truth or he knows something that we don't know. Right. So seeing that look on people's face, the last time I saw that was when I went out and announced a NetScaler running into you that could cache the entirety of Netflix. Right. And people are like, really? How could you? And this was like early days, so Netflix wasn't very big in those days. But it was still that thing that, when you tell it to people, they're like, these guys have done something with technology that we don't yet know how to do. And that look is worth a lot of kind of career satisfaction.
Yes, you saw that in my face when we first talked about Grainite. Of, oh wow, this is pretty cool. So, Abhishek, it's been such a pleasure talking to you. Thank you so much for being here and sharing so honestly and openly about the technology.
Which was a pleasure. Yes.